Hello everyone, welcome to this course on OCI Monitoring Service. My name is Rohit Rahi and I am part of the Oracle Cloud Infrastructure team. In this module, we will describe the OCI Monitoring Service. We will look at the core capabilities of the monitoring service, namely metrics and alarms. And we'll also look at something called monitoring query language. And then we'll have a few demos in between and we'll see how to create a query in the Metrics Explorer and trigger an alarm. So what is the OCI Monitoring Service? OCI Monitoring Service enables you to monitor your cloud resources. Currently it supports metrics and alarms features. Supported services include compute, VCN, networking, load balancer, block and object storage, notifications, and streaming. And over the next few weeks, we will be adding support for additional services as well. Metrics feature relays metric data about the health, capacity, and performance of your cloud resources. And we'll talk a little bit more about metrics in the subsequent slides. But at a very high level, metrics offer a standard set of predefined metrics for most common OCI resources. These are available out of the box for you. As I said earlier, we also have this capability called monitoring query language, which you can use for gaining deeper insights. And then we also support custom metrics, where customers can bring their own metrics. Alarm feature works with another OCI service called notification to notify you when metrics meet alarm specified triggers which you create. And notifications today are sent either via email or via PagerDuty. Like every other OCI service, OCI Monitoring Service is also available via the console, API, SDK, and there is also the Terraform support. So what are the use cases for using the monitoring service? Well, the first use case is if you access the monitoring service, you see these different tabs. The first one is called Service Matrix, and Service Matrix basically surface the same matrix as the resource specific ones, but for all the resources in a compartment. So this gives you a compartment wide view. And this also allows for this particular view also allows you to filter the results with something called dimensions. We will look into that. The second key component of the service is this thing called Metric Explorer. And using the Metric Explorer, you can dive into detail on a specific metric and show multiple resource metrics together. There is also support for a very powerful metric query language, MQL, for running complex queries and gaining deeper insights. The third key component of the monitoring service is are the alarms. So on the alarm, first thing you need to do is you need to create an alarm definition. You create an alarm based on a metric and create a notification via the another service, OCI service called notification service. Today we support email and PagerDuty. And once your alarm has been defined, you can check its status using the alarm status piece of the monitoring service. Both monitoring pages, individual monitoring, this monitoring service, as well as the resource specific charts allow the customer to create alarms directly. So you don't have to go into this piece alarm definition here and necessarily create alarms. Even if you are on a, let's say on a compute service page, you can look at the charts and you can create alarms directly from there, and we'll see that in the demo. So let's look a little bit more into metrics, what they look like, and then we'll show you a few metrics on the OCI console. Like we said earlier, a metric is nothing but a measurement related to health, capacity, or performance of a given resource. Well, the most common metric people use all the time is CPU utilization, and CPU utilization, as the name specifies, measures usage of a compute instance. Anything beyond 80% you have, an instance which is not really operating well, right? Anything from, anywhere from 40 to 80% CPU utilization is an instance which is still operable, but it's hitting the threshold, right? So again, if you need to add more instances, if you have instances running behind the load balancer, you have to scale them. You can add more instances depending on your CPU utilization. Now, the way we define a metric in OCI is like this. We have these three key core components called namespace, dimensions, and metadata. Let's look at them. So namespace is the source service or application that emits the metric. So we have a namespace for compute, which is referenced as OCI underscore compute agent. There is a namespace for block storage, object storage, load balancer, you name it, right? All the supported services, which are supported by the OCI monitoring service today. The second key component is this thing called dimension. Think about dimension as a qualifier to filter or group metric data. So let's say you are surfacing metrics for a lot of your compute instances. You can further filter your results by using a name value pair, like an availability domain. So you could say that show me the matrix only for instances running in AD1 or AD2, right? Again, we'll see this in the demo. And the third piece is the metadata. Metadata is nothing but a reference for getting additional information about a metric. So for example, disk bytes read or disk bytes written would always have a metadata of bytes, and that's the core unit in which that metric is measured. So as you see the example here, if we have a metric, let's say for write throughput, the metric is represented by disk bytes written, and it is actually expressed with all its core components with the namespace OCI compute agent. You can always filter using a dimension like an availability domain, and the metadata is the measurement unit. It will be bytes. Now, of course, you don't need to know all this. I'm just giving you information on what a metric looks like. All this is available out of the box for you. You really don't have to know specific namespaces or specific metadata for specific metrics. Now, there is something called a metric stream, and this is an individual set of aggregated data for a metric. A stream can be either specific to a single resource or aggregated across all resources in the compartment. So let's say if you have 3 compute instances running in a compartment, you could have a stream which has aggregated data from all these 3 compute instances. So let's look at compute matrix, because again this is core to a lot of applications you would be running in OCI. So if you think about an instance, the matrix which an instance emits can be aggregated across all related resources, and we have a single namespace for that, which is called compute agent. So there is an agent running on the instance which is responsible for aggregating all the matrix. So as you can see here, there is a metric called compute agent, and it's measured on the instance itself, and metrics in this namespace are aggregated across all related resources. So for example, a good example would be disk bytes written. This is aggregated across all the instances attached storage volumes. Instance will have a boot volume, can have multiple block volumes for storing your application data. So the metric disk bytes written is aggregated across all those volumes. Similarly, network bytes, whether it's in or out, is aggregated all across all the instances attached virtual network interface cards. So similar to the compute OCI compute agent namespace, we have a block store namespace. and we have a VCN namespace, and so on and so forth, right? And in the block store, you can see that the measurement is done on the block volume service, and the metrics are for an individual boot or block volume. So that is the difference between this one here and this metric here, where one is aggregated and one is for individual boot or block volumes. And the same thing for OCI VCN namespace. It's measured on the networking service, and the metrics are for individual VNIC. Right here we had everything aggregated for that particular instance. So hopefully you can see how the perspective changes if you are talking about a namespace on the compute instance versus a namespace, let's say individually for a block storage or a virtual cloud network. So as you can see, we just discussed this. This instance has a boot volume and a block volume. So these emit the matrix, which you can access using OCI_block storage, block store, and then similar to that, the virtual cloud network matrix are emitted on the virtual network interface card, and you can access them using this particular namespace. And as we said earlier, we support other services like load balancer, object storage, etc. So you have other namespaces available as well. So at this point, it's a good idea to take a look at the console and see how some of these things look like. So right here is my OCI console. I'm logged into my Ashburn region. This is the region I use for my training and demo purposes. I have several compartments here. One of the compartments is the training compartment, and in this particular compartment I am running 3 instances. A couple of instances are terminated, shutdown, are actually terminated, and I have 3 running instances here. So if I go to my monitoring, so first thing I can do is I can click on this instance here. It's a running instance, as you can see here, and if I scroll down, I can see some matrix. I can see 8 matrix. These are available out of the box, and this is the standard set of matrix you get with any cloud provider. So there is CPU utilization, there is memory utilization, there is disk read IO, disk write IO, read bytes, write bytes, and network in and out, right? Network receive bytes and network transmit bytes. So basically all the core components or the core matrix you would expect from a compute instance. So I can see these matrix right here. But if I want to get if I have multiple instances running in a compartment, which is typically how you would be using OCI, and for that matter any cloud, it's cumbersome to go and look at individual instances and look at their individual the matrix. It just becomes too cumbersome. So for that you could access the monitoring service here, and right here you can see that I can surface all the resources within a particular compartment. So first thing I can do here is I can choose my compartment here, right? So I have a training compartment where my instances are running, and right here I can choose the namespace. So we have OCI compute agent, we have block store, we have load balancer, and so on and so forth. Right now I'm looking at compute agent, and first thing I see is I see the same set of matrix, but now I see the matrix across all the instances in my training compartment, and actually all the resources in my training compartment. So if I click on this particular chart, you can see that there is CPU utilization for all my 3 instances. In fact, the web 1 and web 2 running web servers have very low CPU utilization, right? And the other one instance has triggered some load here, and then it's back to a very small amount of CPU utilization, and then again there was some load triggered here, right? So I can have that view across all my instances. Now let's say if I don't want to do that, I can add a dimension here. So I click on dimension, And now remember, dimension is nothing but a way to filter your matrix data. So I could choose availability domain, and looks like my instances are running either in AD1 or AD2. So let's pick AD1, and when I click done, I can now filter it, and now I see there are only 2 instances running in AD1, and I can see both of them here, right? And so on and so forth. All the charts change accordingly. If I want to choose a particular if I want to choose a particular resource, I could even further qualify my results here. So I could say choose my resource ID, and I don't specifically know which resource ID has the one which has the CPU usage, but let's say this is the one. Let me click done, and right here you can see I added 2 dimensions. I added 2 filters. So first I am filtering by AD1, where my compute instance is running, and then I'm filtering by the actual compute instance itself, right? So you can see that its CPU usage was pretty low, then it became close to 60%, then came back again, and so on and so forth, right? And I can see my disk write throughput, read throughput, network in and out, etc., right? So this is how I could use my my service matrix and get a view of all all the resources running in a particular compartment. If I want to see some other matrix, I don't just have to look at compute agent. I could look at load balancer, for example, right? And in the same view, now I can switch between different metric namespaces. So I have a load balancer running. I can see that there are some inbound requests, no SSL connections, bytes sent, how many connections I'm handling, the count of connections here. I'm not running any SSL, so on and so forth, right? So I can see HTTP 200 responses, and I can get some more information here, and so on and so forth, right? So this is actually a pretty detailed list of metrics, and I can switch between different namespaces. So the whole idea is, if you are running a lot of resources, it's very cumbersome to go and look at individual resources one by one. The matrix, the service matrix view here lets you do that, and you can play around. You can see if you want to troubleshoot something going on, you get that aggregate view right here. So let me switch back to my slides and talk about the second key core component, which is the metric queries. So in OCI Monitoring Service, we have this feature called Monitoring Query Language, and this query language expression can be used to evaluate returning aggregate data. And there is a particular syntax for this monitoring query language, and the syntax goes something like this. It looks a bit complex, but it's actually not. It's made up of 5 or 6 components. 5 components are and a bunch of them are optional. So the first one is definitely the metric. So whether you want to have a metric on CPU utilization, or disk bytes written, or a load balancer metric, or object storage metric, you name it, right? So first you define that. The second one is the interval. Interval is nothing but the frequency at which your data points are aggregated. So whether it's 1 minute, 5 minutes, or 60 minutes, an hour. The third one is the dimension. We already looked at what dimension is. It's a filter. You could specify your expression using multiple filters. If you use multiple filters, just separate them by commas. But as we saw in the example, I could add a dimension for AD, and then I could add a dimension for my resource type. There is something called a grouping function, and it has two values supported today. One is called group by, which aggregates your query results by groups. Let's say you have multiple dimensions, so it will group by as many dimensions as you have. And there's something called grouping, which aggregates all query results. It doesn't really matter, if you have multiple dimensions, it will aggregate all the results. And then finally there is the statistic, and this is the function which says whether you want to look at the max of the data, the mean of the data, the sum of the data, the percentile, etc., etc., right? What are some of the examples? You can have, if you want to have a monitoring query language, where you want to look at the max CPU utilization at 1 minute interval, you would write something like this: CPU utilization, this is your interval, this is your metric, and this is your statistic. Right here you can see that I am not using dimension and I'm not using grouping, and those are optional, right? I don't have to use them. These three are mandatory. You need to have those three always in an expression. If I want to have the same expression, but now I want to filter to a single resource, as we saw in the demo. Now what you would do is you would add a dimension here, so you can see my resource. I have that resource in a bracket, and then if I have multiple resources, I could put commas here, and I could have multiple dimensions. I could put a comma, and I can have multiple dimensions there as well. If I want to do for example, if I want to do all read IOPS, if I have multiple disks at 1 minute interval, filter to a compartment, but then aggregated for the maximum IOPS read, right? So now I want across all my disks what is my IOPS, because typically that's how you would get to a specific number of IOPS. You would run a RAID 0 and you would get IOPS across all your disks. So similar to examples above, you have IOPS read here, that's the metric. You have interval is 1 minute. Now you have a dimension which is your compartment ID, and then you have a grouping here, and this grouping is basically aggregating all query results, and then you're looking at the max number of IOPS, right? So this is how you would construct metric queries. Let me show you this in the OCI console. So if I switch back to the console, I have this section here on the monitoring service called Metrics Explorer, and if I click on that, you can see right now I have nothing defined here. So let's do something really quickly. First thing it asks me is what compartment am I planning to use. So I'm using training compartment, that's fine. And then I have to pick a namespace, so I'll pick compute agent. And as I pick the namespace, it has a specific set of metrics. So I would pick CPU utilization. I want to keep it really simple. Interval is 1 minute. That's fine. I want to do a max of CPU utilization. I want to see what it is, and then I'll just click here and say update chart. And if I do that, you can see that the query is written here. And right here you can see that I can see I have a view where I can see all my 3 instances, right? And if I zoom in a little bit here, I can see further details, right? I can click on this view and I can get some more information at a particular snapshot, at a particular time frame. Now I also have the capability to aggregate metric streams. So now it will be aggregated across all the 3 instances, right? And if I click on update chart, first thing you see here is this grouping got added, because that was the whole point of the grouping function, right? And if I go back to my chart, now you can see the view changes, and now the whole thing is grouped by. So it's an aggregate result I'm getting. So if I have running a bunch of instances, in a compartment, which are all, let's say, behind a load balancer, I just want to see the aggregate view, right? I don't want to see individual views. So I have my first query here. I can also add another query. So I would say, now I want to see something like a block store metric. And for this one, let's look at the metrics. Let's say I want to look at the write throughput, right? And I want to look at the maximum value here as well, right? And I have not added any dimension, and let's aggregate metrics, that's fine, and click on that. Now it's a bit difficult to see some values here, and because you have 2 different queries, so I can toggle my query on the chart. So let's say if I remove this one and see, if I toggle this, I'm hiding this one right now, right? So I just see my CPU utilization. If I go back to this one, now I see all my write throughput, and you can see here, right here, that my y-axis changes. It changes from from, you know, when I'm looking at my write volume write throughput, something like 49 KB. If I toggle this view and go to CPU utilization, you can see that the CPU utilization now changes to percentages. So right here looks like 80%, is close to 80%, and right here is below is less than 1%, right? So I can do the multiple queries here. If I want to add filters, I can add filters as well here. So I could add a dimension saying I just want to see 81 data, I don't want to see 82. I could do that here, right? So now it's showing me CPU utilization by 81. If I change to 82, probably I don't have, you can see here that the utilization actually falls in single digits, right? It's actually pretty low. So I can play around. Again, the whole idea here is that if you have multiple resources and you want to gain some deeper insights as to what is going on, you can use the query explorer, and it's get some values, and it's actually it's pretty nice, the way it's laid out, etc. Now I can also have an advanced mode here, where if I want to do if I want to write the query by hand, I could actually do that. But in my opinion, it's much harder. But if you really want to learn what's going on behind the scene, this is a good way to look at it, right? So you can see here the metric is CPU utilization, interval is 1 minute, dimension is 80, and we choosing 82. We are doing a grouping, we are aggregating all the matrix across the instances I have, and then we want to look at the max statistic, right? So this is a nice feature where you can gain deeper insights for your individual resources. Okay, so the last thing in the monitoring service are the alarms. The alarm feature of the monitoring service publishes alarm messages to configured destinations managed by the OCI notification service. So you can use monitoring query language to evaluate for the alarm. An alarm query must specify a metric, statistic, interval, and a trigger rule. Whether you want to have a threshold which you pass, or there is an absence of a threshold, you need to define that. As you can see here, these are also some of the things you use in the monitoring query language. So you could absolutely use that to create your alarms. There are different states for the alarm. Firing just means that alarm has been triggered. Reset means alarm is not detecting the metric firing, and the metric is no longer being emitted. And you can also suppress your alarms, which means that you avoid publishing messages during the specified time range. You can specify a particular time range. It's useful for suspending alarm notifications during system maintenance, for example, or if someone is troubleshooting, you don't want this alarm to be fired all the time, so you could do that. Let me quickly show you how this works in the console. So if I go back to the console, first thing I need to do is I need to click on this alarm definition. I already have an alarm which is defined here, but let's define another alarm. So I click on create alarm. And before we create an alarm, alarm actually depends on a feature called notification. So let's actually do that really quickly. So notification is nothing but a service which has topics and subscription. Think about topic as a channel for sending messages to a subscription, which is nothing but an endpoint. So those are the key components of a topic. So let's create a topic. We'll say the topic is called alarm. And it's basically a topic for sending alarms. I can do tagging if I want. Right now I don't need to, so let's just create that. Oh, so there is already a topic called alarm. Let's say this is alarm 1. Great. Okay, so we created a topic called alarm 1, and if I click on that, now I can create a subscription. As I said, subscription is nothing but an endpoint. So when I choose a subscription, I have two endpoints. I can either do an email or I can do a pager duty. So I'll pick email here, and I'll put my email ID. And hit create. And now as you can see that it would send me a confirmation email to confirm my subscription. And once it confirms, then the channel is we created a channel, the topic, and then the subscription is the endpoint. It can start sending messages to my endpoint, my subscription, right? So if I go back to the monitoring service, I click on alarm definition, and the first thing I need to do is I need to create an alarm here. So I would click on create alarm. I need to give it a name, so I would set CPU threshold, and the severity is critical error. If you just you can define different levels of severity. I would say critical, and alarm body basically says anytime CPU goes beyond 60%, I want to trigger this alarm, right? Now right here I can use the metric query language, the one we just used earlier. So my compartment is training, my namespace is OCI compute agent, and I need to choose a metric like we did earlier. I would choose CPU utilization because that's the one I'm creating an alarm for. Interval of 1 minute is fine, and the statistic what I want here is the max of the CPU utilization, and I can add further dimensions if I want to, right? And then right here there is this thing called trigger rules. So I need to add a trigger rule if for the alarm to be created. So I would say if the CPU utilization is greater than 60%, then trigger this alarm. And the alarm gets number of minutes that the condition must be maintained before the alarm is in firing state. I think a minute is fine. If you guys want to have it a 5 minutes or 10 minutes or something which is longer, you could do as well. So I would do that, and then right here it would say how do I send notifications. So you can see that this is the place where I would need to select my topic. And remember, again, topic is nothing but a channel for communication, for sending messages, and your endpoints are your emails or PagerDuty. So I would say alarm 1 is my topic which I just created, and I could also repeat the notification. So I could say repeat this notification every 10 minutes. So every 10 minutes if this thing is happening, just repeat it, and again you have flexibility of how you want to do it. There is something called suppress notification which we looked at earlier. It's basically when you are troubleshooting, you don't want notification to go, so you could suppress it, but right now let's keep it unchecked. We will trigger the alarm, and then we will suppress it. And of course I want to enable this alarm. Right here you can see that this alarm applies to three instances, because I'm doing an aggregate view, and I have multiple instances in my compartment. I could decide not to do that, right, as well. So so right now you can choose here aggregate metric streams, and the view changes. You can see now it shows me an aggregate, or you could do it one by one. It's fine as well. So you save this alarm, and now if you go back CPU threshold, you can look at the alarm status, and you can see that nothing is getting fired, because my if I go back to my service matrix, I can see that my CPU utilization is actually pretty low. It's less than a percentage, so it's less than 1%. So there is nothing which is getting triggered or fired right now. So let me log into my compute instance. This is one of the compute instances I have running in this compartment, and run a load simulator. So the one which folks are very familiar with is this thing called stress, and this basically is spawning some processes. So it is saying right here, it's saying that I'm running 2 CPU threads, 2 CPU processes. I'm running 2 IO processes, and I'm running some memory process which will consume roughly 128 megabytes, and I want this process to run not just for a minute. Let's say we want to run this for 7 minutes, right? So this is the timeout in seconds, and I give the verbose option so we can see what is going on with running this load simulator. So as I do this, you can see that it's dispatching threads here and running some IO operations and memory operations, etc. And if I go back to my Matrix Explorer and I refresh this page, I can see that my CPU usage would start going up, and very soon I would see right here, you can see that my CPU usage has started climbing up again, right? If I do a max, and this should trigger the alarm as well. So if I go back to my alarm status, I can see that there is no alarm which is getting fired right now, but let's just give it a few minutes, and maybe less than a minute, and the alarm would get triggered here. It took a couple of minutes. Now if we come back to the console, you can see that we had the CPU threshold alarm we just created a few minutes back. You can see the status says firing, and the description is right here, and if I look at the chart here, you can see that the threshold we defined was 60%, and as soon as the CPU utilization went beyond the threshold, the transition state happened from OK, when it was non-firing state, it went to the firing state. And if I go back to the alarm status here, I should be able to see a firing alarm here, which says that my alarm is firing. But right now I can see I can scroll here on my alarm definition, and I can see that the state is the transition state is firing, which means my alarm has triggered. And as soon as my threshold CPU utilization falls back, if I go back to my instance, I can see that the stress load generator is still running, but as soon as it's done, the alarm will reset, and it would say firing, and it would be going from firing to the reset state. So this is how alarms work. I can click on suppress alarm here, and I can suppress it if I want to, right? And that way I would not get a notification. Let's just quickly check once more alarm status. It doesn't show firing, but it should give a list of alarms which are firing in that compartment, right? The topics we discussed today: monitoring service. It includes matrix, alarms, the monitoring query language, and we showed you how you can use all these pieces together. Thank you so much for joining me today for this particular course. I hope you enjoyed.